Hello again. Last week I told you something important. I said this week your idea would become a plan. So your capstone would be something people can read, and this is that week. Okay, we will do both parts today. So here is a simple idea for today. A model nobody acts on is a science project, and work that no one can see is a secret. So today has two parts. First, we will make you good ideas into a playbook, a ranked list of actions. So keep there. This list will show what someone can do. Second, and this is the biggest part, we will learn how to write your research paper. And it will be for the person you want to read it. So we will use the same evidence, but show it in a certain way. So remember the idea. Okay, before we start building, let's answer some questions you asked. So many of you asked when your work will be evaluated. So evaluation starts officially in September. So you don't have to wait for it. So just make sure your repository is a public and your links work. So many of you asked about writing the paper and deployment. So we saved those questions for today. This is where we answer them. If your model got worse under the stricter split last week, keep that corrected number handy. It will be very, very useful today. Okay, let's talk about the playbook. Think about the person using it, not just the model. Our example helps a team decide which pages to review each month. For example, this team can only look at about 50 pages. Per client view can help, but it's a different kind of report. This small number changes everything. When someone can only look at a few things, the order of the ranked queue is most important. And that's why our queue puts pages in order. We choose precision as 50 before we even start the training. On the group split, the numbers are on the slide. You can see clearly there. On the group split, sorry, his GB has the higher observed mean, and the frozen rule sits below it. The base rate is right there too, so you can see how small the gap is. But his GB was higher in 3 held out client folds and lower in 2. So we will show both the higher observed mean and the variation across folds. Now look at the precision at K curve. At K equals 10, the model's observed mean is 52%. The frozen rules observed mean is 38%. The model has the higher observed mean through K equals 75. So from K equals 100 onwards, the rule has the higher observed mean. So this is what we can say. In our 5-fold evaluation, the model had the higher observed mean where our review budget sits at precision at 50. But that advantage was not present past K equals 100. So this doesn't prove reliable superiority. It just shows what we observed and where the observation stops. Your paper needs to have sentences like that. So here is how we make the queue easy to trust. It also answers a question from earlier. We talked about rules and reason codes. So which is better, the rule or the model? Both are good. They do different jobs, and the frozen audited rule supplies the reason, and the model supplies the order. Every item on the queue tells someone what they can do this week. It also shows the reason code and the model score. And there are 4 things to do. First, review before revert. Inspect the spike, check intent, and for hypothesis. We need a control test to see if a change helps. Second, verify, then review. If something changes a lot, more than 7 times, we first make sure it's not tracking or campaign artifact. Third, monitor only. If something has a durable rising trend, We don't change it, we just watch it. And last one, investigate quiet risk. If the model gives a high model score, but the rule returns no flag, a person needs to check it. Just because the model score is high doesn't mean there is a clear reason. The model never tell us why on its own. Now, let's talk about what the queue must never do. Most people skip this part. And there are 5 policies, but the implementation status is not the same. Your paper must say that. New pages are not on the queue. Their momentum might look big but because they are new, right? Durable trend risers are monitor only and never change it. This policy is in a place because we learned from false positive earlier. Things that jump up by more than 20 times go to verification first. A big jump like that might be a tracking or campaign artifact. And these are 3 gates asserted in this notebook. Below floor pages are already excluded upstream by the data contract. Recently optimized pages need a proposed deployment time join that is not implemented yet. So we learned from our error analysis, and each policy tell us where it is enforced. Every step in the playbook needs a quick human review. So did a special event or time of year cause a big change? Is the page still about what people are looking for? Is the client changing things right now? Last week, your AI assistant checked your model and you kept the accept or reject decision. And this playbook gives you editor that the same you editor the same power for every item on the queue. The queue helps you know what to look at. It never authorizes a rewrite. If your playbook can be used without anyone thinking, you made it wrong. Okay, just a second. Monitor has 2 clocks. Before we release the queue, we can check its population, schema, and feature distribution. We have PSI test harness for momentum drift, but this is implemented only in the notebook, not integrated into a production queue. After outcome labels arrive, we can check the new base rate. We can see how the model did compared to the frozen rule. And these post-label checks can change the next queue, but they don't change. They can't change what has already been done. The 4 thresholds you see are proposed policy and not the shift system. So wait for 10 seconds. If June's base rate changed, would we know before June labels arrived or only after? So here's the answer, and the bars on the slide tell it. The base rate rose from about 4 pages in 10 to about 2 in 3. The already dipping list did best that month. The frozen rule fell far below the new base rate. The dev trained model stayed a little above it, but still behind the naive list. Once outcome labels arrived, the proposed outcome alarm would have tripped by the margin on the slide. It would have paused the next release pending review. And one sealed month exposed a material shift. Monthly refitting is a policy to validate, and we still need to look at more time windows. So let's think about how much this costs and how helpful it is. We can ask these questions. Would a plain rule create most of the value with less risk? So our proposed policy answers this question. If the model stays below the rule for 2 labeled months, a human can fall back to the rule. Complexity must keep proving it is useful. And this is still a decision support plan and not the production system. Nobody is deploying anything to servers this week. So then 3 files will come from your notebook. The QCSV, which regenerates and stays out of Git, the precision at K figure, the action mix figure, Keep these files handy. They are ranked recommendation section of your paper. So the first part of this talk just helped build a piece of the second part. So you have a model, validated model, and a playbook. But if you keep them a secret, nobody can learn from them. No one can hire you for a secret. The capstone needs to be shared as a public research paper. It needs special parts. Next week, we will put them together. And they are title and abstract, an introduction that tells the problem, a data section, methodology, results, limitation in careful words, rank recommendations, reproducibility, and acknowledgement with the data credit. And these parts are always needed, but how you write them can change. And that is what we learned today. Before you write anything, ask yourself, who is this for? What do I want them to do? There are 3 doors for sharing your work, and you pick which one you make first, or maybe only one. Door 1 for ML engineers and technical reviewers. They value credibility and work that can answer hard questions. Door 2 for interviewers, HR, and employers. They want proof that you understand ML when you apply for jobs. And door 3 for the SEO community. They want useful, shareable insight they can post with your name. I made 3 examples of how to write about the same capstone. Today, we will look at them closely and see how they are different. Only share them when they are all ready and safe. So the big idea is one artifact can support 3 conversations. The person reading decides what they want to see first. And now, before you share anything, here is an important rule. 4 things never change, no matter who you are writing for. The evidence, the numbers, the limitations, and the methods. You can change the presentation, but never the evidence. If a number is in one page, it must be available in all of them. If a limitation exists in one page, it exists in all of them. And this is like what we learned last week, but in a new way. Today, we will use one capstone about an early warning queue with a sealed June month. We will write it 3 times as 3 finished pages. The abstract, the lead visual, and how the page looks will change. But every single number will be the same. Same evidence with different doors. Okay, this is the job door. 2 different kinds of people will read this part. First, make a fast scan pad for a recruiter to see what you built, what data you used, and what happened. Second, make a deeper pad for a technical interviewer who asks about the split, baseline, error analysis, and code. And these are design targets, not universal reading times. So the page must be layered, but not dumped down. At the top, a title that say what you did, one sentence that tells your proposition and the result card. And this card should compare the baseline with the final result. It should also state the test condition clearly and put links to your code and report where people can easily find them. Below that, give all your evidences bit by bit. So for the person who wants to look deeper into it. And here is our capstone abstract for door 1. It tells what the task is and what the unit is. Then it talks about the main experiment, and 11 feature his GB under client group faults. And as you can see here, it gives the observed mean, the standard deviation besides it, and the base rate. His GB was higher in 3 faults and lower in 2. Then it shows a separate time forward check at 0.620. We also learned in week 5 why the client boundary is important. A different 9-feature random forest went from 0.996 with random rows to 0.496 with client grouping. And we say this was a separate experiment and not part of the main result. The abstract ends with sealed June. The base rate shifted, and the proposed alarm would have posed the next queue after labels arrived. And 1 month is temporal evidence. The refit policy still needs validation, and we are making no causal claim. And when a reviewer reads this, they feel good because every sentence answers their next question. And the stricter, worse number in the middle is not a bad thing. For this reader, it is the best part of the page. And that page is not just a drawing here. It is real on the finished page. And look at the title first. It tells the task, the evaluation design, and what kind of system it is. There are no adjectives that a result would have to prove. So no novel or state of the art under it. Under it, a simple line saying what the paper is about. And when the abstract you just learned, right there, the problem with the metric was fixed before training, the setting with the split and its reason, the methodology, the evidence with the plus minus and the base rate next to it, seal June in one sentence and the limitation as the very last word. So read the last line out loud. The code, random seeds, environment, and the result to notebook map are all given. And that one sentence is a promise the rest of the paper keeps. We will see it in, we will actually see it kept in a minute. Right after the abstract, this paper does something many beginners skip. It numbers its claims. So, claim 1. The model has the higher observed mean near the head of the queue, but not past k equals 100. And this boundary is part of the claim. Claim 2. The evaluation boundary is important as shown by the earlier random forest comparison and not by pretending it was the same model. And claim number 3, one sealed month exposed a material drift, and the proposed monitoring policy tells us when the next decision should pause. Each claim points to the exact section that proves it. So the reviewer's audit is already done for them. And see how claim 1 is shaped. It tells its own boundary. A claim that says where it stops is a claim a reviewer can trust. And now the data section. So see how it is set up. Every choice tells why it was made in the same sentence. One row means one content item at a monthly decision point. The label is an observed outcome and its ingredients are quarantined. They can never be used as a features. So why we kept some things and left others out, each gets because. And then leakage gets its own numbered part as a method and not as apology at the end. 3 boundaries, each checked by code. Feature windows and before the label windows. Clients never cross train task faults, and the seal month was read only once. And there is even a deliberately leaky feature kept as a text fixture. And the text suite proves the frame refuses it. And this is your week 6 audit, upgraded from a notebook exercise into a section of a paper. And when a reviewer sees leakage treated as a method, they start trusting every other section as well. And here is the results table. The random selection expectation 0.416 is shown separately because it is not a train mode method and does not have an across fold standard deviation. The table starts with the frozen rule and the intuitive watch list that scores below that expectation stays visible in the NURBY baseline text. So why show a baseline we rejected? Because a paper that only shows the baseline, makes people ask, what did it hide? So showing the failed idea is easy and it builds real trust. And the caption under the figure does an exact job. What is shown on which folds, what shaded region means, and which direction is better, and most important, which claim this figure supports, and only that claim. The plus minus in the table has its own meaning written down. It is a standard deviation across 5 client group folds, so it includes client differences and sampling variations, and it's not the confidence interval. So a number with explained uncertainty is worth more than a bare number. And we need to show reproducibility as a real root. It's not enough to just say code available. We need to show exactly how we got the results. For example, say this table came from this config and this command, and we need to show the random seeds used and what they control. We also need to show the environment and its versions, and we need to show the data releases and revisions. Your repository already has most of these informations, and this is because you built each weekly notebook so it could rerun from a fresh clone. So it's simple for you to write this part, and it will look very good to people who read it. And it could be a very great deal. And this is the reproducibility route. It is at the end of the paper, near another part called limitations. So read the limitations. One walk forward month is thin evidence. The results are only about client portfolios that stayed active. So we can make a causal claim without an experiment. Each limitation talks about a certain claim you made earlier. They are not just general disclaimers, and that's why they are good. And then there is a reproducibility route. List the environment and its versions, show the random seeds and what they control, and show the run order. The best part to copy is a small result to notebook map. For example, table 1 came from this notebook. Figure 1 came from that one. So this table is easy for you to make because your weekly notebooks already show the route. Also, you need to list your sources. Put each external claim besides its citation. Give dataset and method links when you use them. And have a short reference list at the end. And data credit is good, but data credit does not replace citations. So take a short break and we are moving to the next part. And this is the job door. Two different kinds of people will read this part. First, make a fast scan path for a recruiter to see what you built and what data you used and what happened. Second, make a deeper path for a technical interviewer who asks about the split, baseline, error analysis, and code. And these are design targets and not universal reading times. So the page must be layered, but not dumbed down. And at the top, a title that says what you did. One sentence that tells your proposition and result card. This card should compare the baseline with the final result. It should also state the test condition clearly and put links to your code and report where people can easily find them. So below that, give all your evidence bit by bit for the person who wants to look deeper. And this is the very top of your paper for a job. Everything a recruiter needs to know is in one screen. And the small line about the title tells what kinds of project it is. For example, an applied ML project on a production-derived, pseudonymized warehouse release. The title says what you did. So the preposition names a person and a job. A ranker that puts a central review queue in order, plus a proposed monitoring policy for shifted mode. It does not invent a production deployment. And then comes the result card, and this is how you should make it. Like just two numbers like 0.52 and 0.38. They should be big enough to see from far away. And right under them, stay the condition. What test you did and what data you used. The numbers and their test condition must always stay together. The example also shows three link slots: demo, source code, and full report. So before you share your paper, these links must go to real places. So make the first screen good, even if the reader stops there. And this is how you frame your work, not just try to sell it. What does the reader care about most? Not how sophisticated your model is. They care about your judgment and ownership of decisions. Our capstone has a strong story for a job interview. An earlier test scored 0.996 when the split was random, and the same test scored 0.596 when it was split by client. The page reports the lower number because that is the one that matches real use. It also says plainly that this was a separate earlier test. So here is a trick for interviewers. Write the page so it makes people ask the question you want to answer. For example, why did you split by client and not by row? Why the top 50? What did the simple rule teach you? Where does it fall? Your paper helps you lead the interview, and you already practiced all the answers when you wrote it. So now see how that story works on the page. The split section takes one short paragraph. It gives the two scores, says which one is reported, and says why it matches real use. Then the page returns to the main result. In an interview, this is a more helpful than any accuracy number you could print. It shows you know why a number might not tell the whole truth. And below that, the result table will show uncertainty. And one plain sentence says, well, why the numbers move. The test groups hold different clients. And then the page names its own mistakes and what each one changed. The pages it wrongly flagged were rising, so the queue now protects them. The declines it missed had no warning sign, so a person checks those. Every failure becomes a decision, and this is the ownership the employers want to see. The employer abstract sounds different from the reviewer abstract, and it should. So listen to how it's shaped. It starts with the person. An editor needs to know which pages to review first. Then the build in one line. Then the result 0.52 against 0.38 at the top of the queue. Then the shifted month and the proposed alarm that would have paused the next queue once outcome labels arrived. So same numbers as door one and different order. The person first, the build second, the result third, and the monitoring last as proof of care. And it ends with what would be tested next, because a next step shows growth. And two more parts of the employer paper show you think about whole system and without inventing a production deployment. The sealed June card says that the base rate rose, the frozen rule fell four below it, and the model stayed a little above the base rate, but it was still behind June's naive list. And one sentence does the work. After outcome labels arrived, the proposed alarm would have tripped and paused the next release. And it separates what was measured from what is still proposed policy. And look at the words on the demo mock at the bottom. It says model score, not confidence, because calibration was never evaluated. And the mock is an example and not the live service. The page ends with three clear experiments it would run next. So take another short break and then the last part. And this will be about the SEO community. These people want to know one thing. What should we change on a Monday? They have seen many studies and they make many big claims. So they trust studies that clearly say what they don't prove, and they keep and share these studies. So for these readers, the answer comes first, and there is a TLDR box at the top. It tells them the question, the data, the result, the decision they support, and the biggest limitation. It's a 5 short lines, so they don't have to scroll down. Then every finding is shown in the same way. The finding, what it means, the action, the guardrail, and how to measure if it worked. And our playbook fits right into this. This is why it's called the ranked recommendation section of the paper. And this is the real beginning. The headline isn't the name of the capstone. It's what the reader would ask. Which pages should you review first? The subtitle tells the whole story right away, including the shifted sealed month. And this is because these readers decide very quickly if they want to keep reading. Nothing is kept a secret for later. Under the headline, there is a small row that many people forget, and it helps build trust. It shows the published date, updated date, exact data window, and code version. So search advice changes fast. A study that shows its dates helps a reader in the future know if something is wrong now or if it was true back then. And then there's the TLDR box again: question, data, result, decision, biggest limitation, basically 5 lines. And someone who only reads this box will still understand the main idea. And this is how every part of the paper should be. You can stop reading anywhere and still learn something true. And one chart tells the whole story for these readers. It also teaches 2 good habits. First, the caption doesn't just say what the chart is about, it tells you what to notice. And look at the gap on the left, where you review budget lives. Don't just look at the lines on the right. The shaded region actually says you review budget lives here, and it's okay to show the reader where to look. This isn't a manipulation, it's editing. And second, and this is the habit to copy. Right under the chart sits a colored box that says what this chart does not prove. And it's not hidden far away in the limitation section. It's right there where people are looking. It says this doesn't prove that any feature is a search ranking factor. And it doesn't prove that fixing a page causes recovery. For these readers, the caveat isn't a small detail. It's what makes them trust it. For SEO readers, the sealed June result becomes the decision story, but the evidence doesn't change. The bars on the slide show it. Among eligible pages, decline label base rate rose from about 4 in 10 to about 2 in 3. The frozen rule fell below that new base rate. The model stayed about, and the naive already dipping list did best of all. After outcome labels arrived, the proposed outcome alarm would have paused the next release. And this is correct and helpful. It's also less dramatic than saying the whole portfolio fell or that an alarm stopped actions before they happened. And one sentence must always be with you what you share with these readers. This is a predictive and not causal. A predictive feature is not a search ranking factor. So we observed, we measured, we support decisions, we made no causal claim. For these readers, that sentence isn't fine print. And it's what makes your study different from the many other studies they stopped trusting. And now the part these readers really care about. This is it's on the actual page, and every finding uses the same repeating shape. There is the finding with its number and what it means in simple words. Action, what do you do on Monday? And what do you not do? The guardrail and it is its own in its own color. It works because a study that tells you when not to do something is one you can safely follow and measure how you will know if it worked. Our playbook action fit into this shape almost perfectly, and that value without trying to sell anything. The box said derived arithmetic with its assumptions, and the box showed the derived arithmetic about six more label decliners in a 50-page review batch. And there is 50 times the gap between two-fold means printed right there with its assumptions. And this is a descriptive scenario when from the five-fold evaluation and not expected future impact. And derivation and assumptions are in the box. It doesn't claim traffic recovery because that needs a control test, and we don't have it. And visual assumptions are better than making a big promise. And your paper for these readers also becomes other things. It can be a social media post about the methodology. It's also the start of what you will formally write in week 8. The social media post has a sad shape. The question, one finding with its exact scope, what changes in the workflow, the limitations explained clearly, and a link to the paper. So one chart, never just a number with its denominator removed. If the post says 52%, it also says where the top of the queue on a test of size the model had never seen. And the caveat is not damage control. And on social media card, the caveat helps make people trust it. A post that states its limitations give people enough information to know if it's worth sharing. So all of this is in one picture, the same precision at K curve, drawn three different ways. We just seen all three of them on the real pages. For the reviewers, both curves, every K point, the base rate line, a fold variance note, and a caption that cleans the split metric and the uncertainty. For the employer, only the head of the curve, one call out, the observed mean was 0.52 compared with 0.38 at K equals 10, and the test condition. And lastly, for the SEO reader, an annotated card, high observed mean near the top, but no advantage past K equal 10, K equal 100, with the words predictive, not causal, written right on the picture. And direct labels and different line styles mean color isn't the only way to tell things apart. It's the same evidence. So three different drawings and zero new numbers presented just in different way. So no matter which door you pick, the page itself has a floor, and there are three reading depths. First, scan, look at the title, one result, and one picture. Second is evidence, read the data, methods, results, and limitations. And three, audit trail. Look at the configs, random seeds, and commands. A person should be able to stop reading at any given point and still learn something true. Headings should say what the section is about. Links should say where they go, like reproduce the main table, not click here. The words should be big enough to read on a phone. The page should have a real contrast. So if a chart needs colors to make sense, label the lines, and every chart should answer one question and show its units. The page should work even if you don't open a single fold. So put each external claim besides its citations. Give durable links for the dataset and methods. So keep references at the bottom. Data credit tags the source. It does not replace citations. All these things are important. And this week, your notebook is the playbook. It shows what we did in the first part, step by step. And section one, ranked actions with reason codes. So mix your role and your code. The rule explains and the model orders. Section two, intended use and limitations. Who uses it, when, and what it colors. Section three, human review and the no-go list. Say what is sorted, upstream, or still proposed. Section 4, monitoring and retraining triggers. Separate pre-release checks from post-label checks. Say what is implemented, and that's it. Section 5, export for the paper. So keep the QCSV out of it and commit only figures and metrics. Yeah, let's keep track of our own work. We still need to do more from our audit. We checked only one time forward month. More time window would make our claim stronger. So put this in the limitation section of your paper. Also, don't know if a content refresh causes recovery. We haven't tested this, so don't make a causal claim. Only a real experiment will show it, and pretty much that's it. Make sure to submit your repository and make it public. And next week, we will review some of your submitted works. I will review capstones and stuff. So be there and see you next week.